Section 8.4a is about polynomials. The definition of a polynomial is a monomial or a sum of monomials. If you have something like 3x squared, that's a monomial, that's an individual term, but when you add something else to it, now it becomes a polynomial. Now, technically, one monomial is also considered a polynomial, but when you add or subtract another monomial with it, then you begin to call it a polynomial. Specific kinds of polynomials are binomials and trinomials. Binomial is the sum of two monomials. The prefix bi means two. So you see our example up on the top is a binomial. There are two terms, and you can see them separated with a plus sign here, 1, 2. Now if they were separated with a minus sign, it would still be a polynomial or a binomial. Trinomial is a sum of three terms, so if you have 4x minus 3y plus 2x cubed, that would be a trinomial. You can see one term, two term, three terms. They're separated by the plus and minus signs, and that makes up a trinomial. In these examples, we have to tell whether they're a polynomial, and if it is, we have to say monomial, binomial, or trinomial. Well, let's look at this first one. I see one term, I see two terms that are each monomials. Put them together, and it becomes a binomial. Over here, this one, I see one term here, but this second term is interesting because 5 times n over 2 is really 5 times 1 over n. And remember, we can't divide by a variable. So this second one here is not a polynomial. The next one, negative 8, it doesn't have any variables with it, but it's still a monomial. It's still one term. It's called a constant. And so this one is a polynomial, and specifically it's called a monomial. Here we have some more definitions. The first is a degree of a monomial. Well, a monomial is a single term, and the degree is the sum of the exponents of its variables. So if I have 4x squared y, and you look at the variables here, you'll see an exponent of a 2 and an exponent of a 1. So the degree, we would say, is 3. Whereas this one over here, if I have just an 8, there are no variables, so the degree of this would be 0. Because you take all the exponents on the variables only and you add them together. Now, to find the degree of a polynomial, you take the greatest degree of any term in the polynomial. So let's look at that. 4x squared y plus 3x minus 9yz. If you look at this polynomial, it has three terms, and what's the degree of each term? Well, the degree of this term is 2 plus 1, or 3. The degree of this term is a 1, because it has a 1 in that exponent. And the degree of this term is a 1 plus 1, which is a 2. So the degree of the whole thing is 3, because it's the greatest degree of any individual monomial that's in the polynomial. Here we're going to find the degree of each one of these monomials, and then at the end here we have a couple polynomials we're going to find the degree of. We'll start right here with 8y to the 4th. Remember, the degree of the monomial is adding the exponents, so this one has a degree of 4. This one here, 3a, we don't care about the 3. What we care about is the exponent here on the a, so the degree for this one is a 1. Next monomial, this x has a 1 on it, so 1 plus 2 plus 3 is 6. So the degree of that monomial is a 6. Here there are no variables, and so if there was a variable here, like an x, it would actually be an x to the 0, because x to the 0 equals 1. So we would say the degree of this, since there are no exponents, is 0. 5mn squared, there's really a 1 here on the m, so we say the degree is 3. And now we have to find the degree of this polynomial, which means we find the degree of each individual monomial. The degree of this term is 4, the degree of this term is 2, and the degree of this term is 0. So the degree of the whole thing is the biggest one of those, 4. Next polynomial, the degree of this term is 1, this term is a 2, the degree of this term is a 3, and the degree of this term is a 0. So the degree of the whole polynomial is the largest of those, 3.